All right, we're back. We are on page 120 of math analysis. We are talking about vectors, two-dimensional vectors. We just talked about component form and define component form. It looks like an ordered pair, but we use chevrons. So instead of parentheses, a vector for us is going to look like a chevron, and then, oh my God, that's supposed to be a delta, delta x, delta y, and then this. And then when we find delta x and delta y, it's really important that we do terminal minus initial because the order matters. Like the other place where you've probably seen delta x and delta y at this point in your life is with slope. And with slope, as long as you're consistent, it doesn't matter, right? You can do y2 minus y1 over x2 minus x1, or you could do y1 minus y2 over x1 minus x2, as long as you're consistent. Here it matters. You have to do terminal point, the place where you end up minus the initial point, to make sure that you get the change correct. So we got to make sure that we're doing that. And so that's component form. It looks like an ordered pair. It's basically indistinguishable, really. And if you remember, when we first started these, I mentioned that I kind of view vectors as just another way of writing points, and they allow you to do new things with points. And some people probably really don't like that, that notion. But it's how I view them to begin with, and then we use them for other things. So let's see. Write the component form of each of the vectors. So we have a u and a v. So u, if you look at it, I mean, all we really need is that terminal point because its initial point is already at the origin. And that's what's so nice about component form. So here, we're going to say that that's 1, 4. So u, and when you handwrite it, you put a little arrow over it. So u is 1, 4. And then v, a little arrow over it. It's really annoying that u and v are the two letters that you use. Because they, if you're not careful, they look alike. So here's 3, 2. 3, 2. Okay, so now I want to find u plus v. I want to add two vectors together, which is saying like, I'm going to give you two sets of information and you're going to do both those things. So the first one is move 1 unit to the right, 4 units up. The next piece, when you get there, I'm going to give you another piece of information. So you show up there and I'm like, all right, now move 3 units to the right and move 2 units up. So what we're doing is we're just adding together that information. So if I do u plus v, and if you've done matrices before, this is just like adding matrices. So it's going to be 1 plus 3, and then 4 plus 2. So I'm adding like corresponding things. So here, and then it's always weird. Like I'm not really a color person here, a user of colors. But I do think that it really highlights what we're doing. So we get this. So the end result here is 4, 6. So what that's saying is, instead of giving you one piece of information, making you do it, and then when you get done with that, giving you a new piece of information, making you do that, I could have just said, hey, from your initial point, just go 4 units to the right and 6 units up, and you'll be done. So let's see what that means graphically. So 4, 6 is here, right? So I'll use a different color for this. Let's see. So 4, 6 is here. So the vector is here, right? That's the vector 4, 6. Why is it 4, 6? Because it starts at 0, 0. It ends at the point 4, 6. So that's the component form of the vector. That's 4, 6. So now what I want to do is, if you look graphically, what we could have done. So let me see here. All right. So say I'm going to highlight the vector v here. What if I pick that vector up? I'm literally picking it up. And so it says go 3 units over and go 2 units up. So what if from this point, I go 3 units over and 2 units up? It puts me right there. So what I'm actually going to do is draw this. And this is the vector v again. So if you look at that, what we did was first, I need a color. Okay. So first we went whatever u told us to do. And once we were done with u, we did whatever v told us to do. And by doing that, can you see that we're kind of creating a parallelogram? So I don't know, I don't think about these parallelograms very often, but it is a thing that What if we had done v first and then u, right? So v said go 3 over and 2 up. So that puts us here. 3 over, 2 up. That puts us here. And then once we're there, I hand you a slip of paper and it says, now use vector u. Vector u is 1 unit over and 4 units up. So if I go 1 over and 4 up, I end up in the same place again. So what I can do is this. It turns out that the order in which I do this doesn't matter. I'm going to end up in the same place anyway. So this vector, this kind of, I don't know what color this is, that vector is u plus v. It's also v plus u. Doesn't matter which way you think about it. So that's kind of the parallelogram that shows up when you do that. So let's try this with subtraction. So subtraction's a little bit different. It's not bad, but it's a little different. So they're the same vectors, so u is still 1, 4. So u equals 1, 4, which is just the terminal point. That's the whole point of component form. And then v is 3, 2, which again, just the terminal point, which is the whole point of component form, is that you don't need to know like where you're starting, where you're stopping. You just need to know the terminal point because you're assuming you started at the origin, and then it's just the set of information, right? Both of these are just delta x comma delta y, which is really, really useful. So now I want to do u minus v. So this will be 1, what am I doing? 1 minus 3, 4 minus 2. And if we were to kind of color code these, you know, it's funny, I like color coded everything and then I just like did it wrong. Well, I didn't do it wrong. I'm going to change these. Oh, can I do that? Oh, no. Hold on. I'm gonna try to use the same colors that I used. Really, there's absolutely no reason for this. U is this color and this color, this color and this color. I mean, if you really like these colors, I'm kind of jealous, to be honest. Like, you know, character flaw. I sometimes talk down about things that I'm jealous of. Here, 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 here. I just in person, like using actual physical media, it never occurs to me to change colors. So we get this. All right, so this will give me 1 minus 3 is negative 2, and then 4 minus 2 is 2. So instead of telling you to first move 1 unit to the right and then 4 units up, then when you get there, I give you a slip of paper and I say, now subtract this. Now go the opposite of what I just handed you. So what does that really mean? Like go the opposite of what I just handed you? Well, another way of thinking about this is to say that it's the vector u plus the negative or the opposite of vector v. That's how we're going to think about this graphically. So let's see if we can do that. So my first thing that I'm going to do is I'm going to create a new vector that is going to be negative v. So if v is 3, 2, so go 3 to the right and go 2 up, negative v would be 3 to the left and 2 down. So 3 to the left, 2 down takes me here, which means my vector will be, so I'm going to do the thing where I put it kind of in the middle there, just so things don't get too cluttered. They're going to end up cluttered anyway. So that's negative v. So now think about what we're doing, right? I give you a piece of information. I say, move the vector u, which is 1 unit over and 4 units up. That puts you here. Then you end up there, right? So you've started at that point. So let's say you did this. Oh, that's not a highlighter. You went like this. Okay, that's your first move. So now you're sitting at 1, 4. Now I give you a slip of paper and I say, these are your directions, follow them. And the directions say negative v. So negative v is 3 units to the left and 2 units down. So let's do that. So 3 units to the left, 1, 2, 1, 2, 3, and then 2 down. That was not 3, 1, 2, 3, and 2 down takes me to this point. So we will go here. Okay, and I'm gonna put my arrow there so that it's not too bad. And now the final vector that we're gonna draw, you go from the initial point. So the initial point is the origin. That's where you started out this whole journey, to the terminal point, the last terminal point that you made. So we're gonna go from the initial point to the terminal point, which gives us this, which is the vector u minus v, or u plus negative v. But the key thing is that this point right here is negative 2, 2, which is what we got when we did it algebraically. So it's kind of interesting that you end up with this no matter what. Now, I do not like the parallelogram rule for this. I guess what you could do, or what you could at least observe, is you could observe that this is 2 to the left, 2 up. If I start here and go 2 to the left and 2 up, look at that. It's this terminal point can be connected by that vector. So here, now remember, it doesn't matter where you draw this vector, it's still the same vector. So this is also u minus v, but that's also u minus v in the same way that, I don't know, like this is also u minus v, because it's also 2 to the left and 2 up. So however you like to do that, it doesn't really matter. All right, you know what I'm gonna do? I'm gonna stop this video here. I'll come back in the next video and just do the next problem, because I feel like this is getting long, but it's really hard to say. So anyway, I'll see you in the next one.